Hello, we are Ricardo and Sania, and we are going to present the Millikan experiment. The objectives and specific goals for this practice is to obtain the charge of a drop of oil through the Millikan experiment and to
Oye,
use.
espérame. ¿Tú tienes en lo de tomar control?
Sí, ¿por qué?
Porque, a ver, pícale.
No, tengo tomar el control, no. Qué
Ya.
pendejo.
Ajá. Porque dije, ¿por qué no se cambia?
Ok, no lo tenía. ¿Sigo grabando o...?
Sí, sigue grabando. Nada más vuelve a
Va,
poner el temporizador.
sí. Hello, we are Ricardo and Sania, and we are going to present a Millikan experiment. The objectives and specific goals for this practice is to obtain the charge of an oil of drop. ¿Qué? No, aguanta. Así no era. ¿Ves? Okay. Hello, we are Ricardo and Sania, and we are going to present the Millikan experiment. Our objective for this practice is to obtain the charge of a drop of oil through the Millikan experiment, and the specific goal is to using the velocities of the drop calculate the try to calculate the charge of an electron.
The introduction and the theoretical framework, we're going to start saying that in the beginning of the 20th century, A. Millikan designed an experiment that allowed him to determine the charge of an electron. This experiment consisted in spraying charged oil droplets between the plates of a capacitor and observe their behavior as they rise or as they fall. And we can see the Millikan's experiment in the first figure. Here you can see the capacitor and the atomizer that sprays the oil. Now, if there is no electric field, the droplets will fall due to gravity, and we can obtain the falling velocity by analyzing the forces acting on the drop of oil. And in the first diagram, we represent the forces that act on the drop of oil, and we can also obtain through this the equation that relates the forces. Next, please. But in the other hand, if an electric field is then applied on the droplet, it will begin to rise with that velocity Vr. And this will happen if the superior plate has a positive charge and the inferior a negative charge. We can also obtain an equation that relates the forces by analyzing the force diagram, as we can see here when we have an electric field. Now, if we relate the first equation of forces with the second one, with that has the electric field, and if we know the density of an oil droplet of radius A, that is given by the mass over the volume, we will obtain the charge of the oil droplet that is given by the last equation, and then it would be also possible to obtain the charge of the electron if we analyze multiple drops of oil and we obtain the difference between their net charge, because their net charge will be a multiple of the fundamental charge of the electron.
The materials used for this practice was a Millikan oil drop apparatus and atomizer, a non-volatile mineral oil, a digital multimeter, a paper screen, and a digital stopwatch. The methodology used was with the atomizer, we placed some oil drops in the apparatus, and we could turn on the electric field and see some of these drops falling, and then we changed the charge of the apparatus, with polarization, and then we would see the drops rise. This is a video of the measurement of the drops. We could only see one drop rising and then falling. Yeah.
Now we're going to begin with the analysis. As we saw in the introduction, we need to find the velocity at which the drops fall or rise. Since we only could observe one drop of oil, we both did the measurement for that drop of oil, and we obtained the values of the distance traveled in a certain time. With those values, we obtained the velocity. The error of the velocity was obtained with the first equation on the left side, right side, sorry, on the right side. And then we obtain the average value of the velocity of rise and the velocity of fall, and we obtain the values presented at the bottom of the slide.
To obtain the charge, we needed to first know the radius of the drop. We use the equation for A, where P is the pressure of 1 atmosphere in pascals. We use the density of the drop, the viscosity, and the constant B given by the manual. And with the equation on the right, we calculate the error for the radius, and with that we obtain a value of A. Now that we know all the parameters, we can obtain the net charge for the drop with this equation, and we use the equation for E equal to the voltage over the distance. And with the equation on the right, we could obtain the error for the charge. So that gave us a value of the charge. Given that we could only see one drop of oil, we couldn't calculate a experimental value of the charge of an electron, like Millikan did. Millikan obtained the value of the charge for many drops, and he could see that that charge would be a multiple of one number, that number being the net charge of the electron.
So in conclusion, we successfully obtained an experimental value of the charge carried by a drop of oil. We obtained a value of Q equal to 14 plus minus 0.9 times 10 to the minus 19 coulombs. And we also discussed how it would be possible to obtain the charge of a single electron, analyzing multiple charges and determining their difference in net charge. We would be able to obtain the fundamental charge of an electron. And these are our references. Thank you.